Welcome to Weighted Queries with Carbon LDP. During this tutorial, you will learn how to execute weighted queries with SPARQL and Carbon LDP. Weighted queries allow us to do searches in our databases and give our users structured results to provide meaningful information. For this demo, we are using a database containing information about movies. We can see the structure of this database on the left, and we have a container of movies that has documents of type movie and a container of persons with documents of type person. A movie document has the following properties: name of type string, date published of type date, and actors, which is an array of relationships to documents of type person. To start with weighted queries, we are beginning by doing our queries with SPARQL. For this, we can use any type of SPARQL editor. In this case, we are using Carbon LDP's SPARQL client. For our query, we are using the following prefixes. The first one belongs to our database, movies, and the second one belongs to the schema vocabulary, which will allow us to define some properties further on. Our query is going to be a select all so that we can see all the data we include as wildcards. However, we are limiting the results to 20 to have an easier handling of the retrieved information. For clarity, we are dividing this weighted query into two sections. The first will be addressed to get the candidates, which retrieves the results in a general way. The second is assigning a weight to the candidates to order them and filter any candidate that does not have weight providing more significance to the results. To retrieve our candidates, we are requesting all the documents of type movie, as well as their names and date of publication. This allows us to retrieve only movie documents and leave the person's documents out. Once we have the movie's properties, we are filtering them via their name property using a regex function, validating that their values include the words dark and night, since we are looking for the movie title Dark Knight. Finally, we are giving the regex function an option to ignore uppercase and lowercase letter on the results. Up until now, this simple query is retrieving all the movies that contain these two words in their title. As we execute this query, we see several results where movie titles that contain the words dark and or night, and in the second last result, we can see the movie The Dark Knight, which we originally wanted to get. Nonetheless, we are still missing the weight in each movie, so to see that, we must assign the weight. We erase the previous results and then continue with the weight assignation. To do so, we are using the bind function, which allows us to add data to our results. This data will be saved as weight and will be a result of our weight criteria. A weight criterion is what assigns a weight unit to our results in case the condition is fulfilled. The first weight criterion we are using is having all the search terms in order somewhere in the name property. To make this happen in SPARQL, we are using the replace function. We are replacing the name property using regex by replacing the words dark and night with bars and ignoring upper and lowercase. This new query is assigning more weight to a movie with a bar if the movie title has those two words. This helps us use these bars further on as the weight of our movies. If we execute this query, we can see that now our results have a weight variable and most results have the name of the movie assigned in the variable weight, except for the one that matches our condition, which is the Dark Knight movie. Since we want to use the weight property to order the results, we don't want to have the names repeated in this property. We can do this with another replace function. We are nesting the previous replace function and add the following condition. Every result that does not have a bar, replace them with an empty string. Once we execute this updated query, we can see that those results that do not meet the condition have the weight property empty. Our next step is ordering our results according to the weight assigned. We do this by adding an order by clause, giving the weight property as a parameter, and we also add a second order condition, which is updated by date published, in case there are two or more results with the same weight. The reason to do this is that when working with linked data, the order of results can be random, and having two ordering criteria would prevent this from happening. If we execute the updated query, we see two results that match our query, ordered from newest to oldest, leaving the rest of the results just ordered by date published. We can do a more detailed query. Our weight property is of type string, so we can add new criteria nesting a concat function. The idea behind using concat is having all our criteria together and concatenating the results. In doing so, only bars are assigned in the weight property. We are adding some additional search criteria and we'll discuss what each criterion does. To start, we are looking for results that have all the search terms in order, somewhere in their title property. First, the word dark, then the word night. The second criterion specifies that all terms must be somewhere in the property, regardless of their order, as long as all the terms appear in the property. Finally, this criterion specifies that the first term appears as the beginning, in this case, the word dark. When we execute this query, we can see that some results have two bars because they met more than one criterion, and then those that only met one of the criteria follow. Until now, we have done this example in a static manner, but we want to be able to use this with several terms. To do this dynamically, we are using JavaScript and Carbon. This is a React project using TypeScript. What we're doing here is a search service that allows you to use a search function to get you the results. This function uses the query we just created. We have some utilities we will use further on to get more information. Using the query created and Carbon LDP instantiated in a variable called Carbon LDP to demonstrate this. Our movie service has a search function which can be called from any place and returning a promise of type movie. The movie object is an interface that has properties that any movie has, just as we saw earlier, name and date published. This function receives parameters as search terms, which are strings users will type in the search bar when looking for movies. Then, offset and limit are numerical variables that help us with pagination. Finally, detail level was added by us to get the details of the movie resulted from the queries, but this is not mandatory. To make our query dynamic means to obtain the terms from the users. We get them as strings divided by spaces, and this will result in an array of strings. As you could see earlier, we used backslash as a word boundary in our regex function. Note this: when we use Carbon LDP with JavaScript, all backslashes should be duplicated. We assign this to a variable for aesthetic reasons. We now have this variable called SPARQL body, where for the first section we are getting the prefixes from a function called getMovixSparkle prefixes. This makes it easier further if we decide to do other queries. After this, we can see that we have the same query we did before. We will now only have to change what we had in a static form for our dynamic variables. In this case, instead of using the words dark and night, we are using the variable term which contains the terms provided by the user. We are using our word boundary variable as a first instance and then a map method to generate an array of strings and finally a join to get the string that we want. We do the same thing for the other functions where terms are involved to make this dynamic. Once the other functions are updated, we set the offset and limit dynamically as well at the end of our query. We now have our query ready. We can execute this with Carbon LDP's documents endpoint and the execute select query method, giving a SPARQL body as a parameter. We should get a promise back and assign it to query results. Since we get an object back, we are extracting from the bindings property the results of our search and we assign them to a variable named movie results. Movie results now contains an array of Carbon LDP documents which allow us to do extra steps, like the next one. Since we get back empty documents without properties, we can get those with Carbon's documents reader. We can get this through a function movieUtils and the details method, which gets the details from the results stored in movie results, which are being stored in the detail results variable. We now return detail results. Let's now head over to our demo and see this live. When typing Love Coopers in this search bar, we can see that our first result is Love the Coopers, since this is the result that better matches our search criteria. Then Love and Friendship, and so on. If we tried this with the word dark, we also get the results that match our search criteria, and you can see them ordered from newest to oldest. If we detail our search a little more, we see we can get the same results as in our first exercise. With weighted queries, we can get filtered results that meet our criteria, and we can add as many criteria as desired. This allows us to deliver information more conveniently. Thank you for watching this tutorial. If you want to learn more, follow the links below and hit subscribe to get our updates.